will discuss a topic of symmetry. Okay. So what do you mean by symmetry? Symmetry is nothing but it is a character of beauty. See, when you draw a rangoli, so when do you say that it is beautiful? Means if the given rangoli is uniform throughout the drawing, then you will say that that rangoli is beautiful. Yes, why that beauty comes to the picture? Because of the uniformity. So when you come to geometrical figures, so those geometrical figures, because of this uniformity, the geometrical figure gets beauty. Yes, they gets beautiful. That is why we can say that that time the given geometrical figure have a symmetry. See, so the symmetry is nothing but the quality of uniformity which gives beauty to the geometrical figures is nothing but a symmetry. See, symmetry usually two types. The first one is line symmetry and the second one is rotational symmetry. And this line symmetry is also called as reflexive symmetry. Reflexive symmetry. And in this rotational symmetry, we have a subcategory that is point symmetry. So the point symmetry comes under rotational symmetry. Now in this video, we will discuss line symmetry. Okay. When do we say the given geometrical figures have line symmetry? Means if you, so you take the figure first. So if you draw a line, so about that line, if you fold the two parts of the figure, means if you fold the two parts of the figure about that line, if those two parts coincides with each other exactly, then we can say that that figure has a line symmetry. Example, see you take one example. This is one figure. Okay. Now, if you draw a line, this is the line. So, about this line, if you fold, this is one part of the figure, this is one part of the figure. If you fold the two parts of the figures about this line, means if this is the middle line, if you fold like this, those two parts of the figure coincide with each other exactly. Then we can say that this figure is symmetric as well as it has a line symmetry. Yes, this line we call it as a axis of symmetry or symmetrical axis. Okay. And we always represent a line symmetry with a dotted lines. Okay. So these dotted lines we can represent. See, if you take this figure, now you tell me how we can draw a line, means symmetrical axis. How can we draw symmetrical axis to this figure? Whether this figure is symmetric or not. Yes, now we will see. See, if you take a line, axis of symmetry like this. Yes, about this line, if you fold this figure, these two parts of the figure coincides with each other exactly. Yes, so that is why we can say that this figure is symmetric. Yes, and if you draw line like this, what happens? If you fold like this also, the two parts of the figure coincides with each other, isn't it? Now, this is also one more line, axis of symmetry. Yes, this is one symmetrical axis and this is one more symmetrical axis. By this, we can say that the symmetrical axis may be horizontal, may be vertical, may be above the corners also. Means sometimes, see, if you take an alphabet X. See, if you take this figure, if this is a symmetrical axis, yes, if this is a symmetrical axis, if you fold this figure about this line, will the parts of the figure coincides with each other? Yes, these two parts of the figure coincides with each other. But this line, this symmetrical axis is about the corner, isn't it? That is why we can say that the symmetrical axis may be horizontal, may be vertical, may be about the corner. Okay? And does all the geometrical figures have symmetry? Need not be. Some figures may not have symmetry. For example, if you take this figure, now can you show me symmetrical axis for this figure? Means if it has symmetrical axis, then we can say that the figure is symmetric and it has line symmetry, isn't it? But we cannot draw any symmetrical axis for this. Suppose if you draw symmetrical axis like this, will the parts of the figure coincides with each other? No, right? The parts of the figure don't coincide with each other. If you draw a symmetrical axis like this, then also they don't coincide. That is why this figure is not symmetric. Not symmetric. It doesn't have any line symmetry. It is not symmetric. These all figures are symmetric. Okay. Now, every geometrical figure need not have line symmetry. Means some geometrical figures may have line symmetry. Some geometrical figures may not have line symmetry. Yes. So, all geometrical figure need not have line symmetry. And some geometrical figures may have more than one line symmetry. Means, see, for this figure, you see this is vertical, this is one symmetrical axis, this is also a line symmetry, as well as this is horizontal, this is also line symmetry. It has two line symmetry, isn't it? So that is why geometrical figure may have more than one line symmetric also. They may have more than one line symmetry also. Now we will discuss the symmetry of English alphabet. We have A, B, C, D up to Z, right? So for all those alphabets, we will discuss symmetry. Okay. So now we will discuss line symmetry and nature of all the capital letters of English alphabets. See, if you take an alphabet A, see, this is a symmetrical axis. Yes, it is. This figure is symmetrical. Yes, it is symmetrical. And how many lines of symmetry are there? So one lines of symmetry. Yes, it has one lines of symmetry. And when you take B figure, yes, it has, this is the symmetrical axis, isn't it? So this figure is also, it is symmetric. And how many lines symmetric are possible? So how many lines of symmetry? So for this also one lines of symmetry. But for this it is a horizontal lines of symmetry. But for A it has vertical lines of symmetry, isn't it? So when you look at the figure C, so it has one lines of symmetry. It is symmetric and it has one lines of symmetry, as well as it is horizontal lines of symmetry, isn't it? So this you have to remember. Means sometimes in the exam they may ask the questions that for an English alphabet, so and so alphabet he will give you. So he may ask the question that how many number of line symmetries are possible, whether the given figure is symmetric or not. So that type of questions they ask. That is why we have to identify the given figure is symmetric or not, and we should count the number of line symmetries are possible. Okay. So when you see the figure D, yes, it has one line of symmetry. It is symmetric and it has one lines of symmetry, and that two horizontal line of symmetry. Yes. And for E, it has one line of symmetry. So it is symmetric. It has one line of symmetry, the two horizontal. When you see the figure F, I can't draw any symmetrical axis for F. So it is not symmetric. So it is not symmetric. And if you see the G, for this also I can't draw symmetrical axis. That is why it is also not symmetric. And for H, see, this is one line of symmetry. This is another line of symmetry. So it is symmetric. It has two lines of symmetry and one is vertical and one is horizontal. Yes. For I, see, this is one line of symmetry and this is another line of symmetry. So it is symmetric and it has two lines of symmetry and one is horizontal, one is vertical. Yes. And for J, we can't draw any lines of symmetry. So it is not symmetric. And for K, so it has one line of symmetry. So it is symmetric and it has one line of symmetry, the two horizontal. For L, it is not symmetric. We can't draw any symmetrical line for this. And for M, it has one line of symmetry. So it is symmetric. It has one line of symmetry, the two vertical. And for N, it is not symmetric. And for O, when you come to O, see, we can draw, this is one line of symmetry, this is another line, this is one more line, this is one more line. If you keep on drawing line of symmetries, we can get infinite number of lines of symmetry, isn't it? See, means O is looking like a circle. That is why we can draw infinitely many lines of symmetries for that. Yes, that is why. So how many number of? There are infinite number of lines of symmetries are possible for O. And when you take P, so we can't draw any lines of symmetry. That is why it is not symmetric. Okay. For Q, we can't draw any lines of symmetry. That is why it is not symmetric. And for R also, it is not symmetric. And for S also, it is also not symmetric. And see, if you take a letter T, say we can draw one line of symmetry. So it is symmetric. It has one line of symmetry, that two vertical. Yes. And if you take U letter, so this is one line of symmetry I can draw. So it is symmetric. It has one line of symmetry, that two vertical. And if you take a letter V, this is also symmetric. It has one line of symmetry, that two vertical. Yes. And if you take a W, this is also has one line of symmetry. It is symmetric. It has one line of symmetry and that too it is vertical. See, when you take a letter X, so this is one line of symmetry and this is another line of symmetry. This is one more and this is one more. So how many number of line symmetries are possible? One horizontal, one vertical and along the corners two. So total it is symmetric. It has four lines of symmetry. One is horizontal, one is vertical and two are along the corners. Okay. If you take a Y letter, so this is not symmetric. We cannot draw any lines of symmetries. And this is also not symmetric. We can't draw a symmetric line for this. Yes. So these are the English capital alphabet which have symmetry and some letters don't have symmetry. Some letters have symmetry. Yes. So we will discuss the symmetry about a plane figures, means line of symmetry of a plane figures. We will discuss in the next video. Thank you.